Welcome, guys, to our class for today. I hope you are doing good and you are enjoying our physics class. Is that okay? So, for today, we'll be looking at the application of gas laws. Application of Boyle's law to a trapped gas in a cylindrical tube by column of mercury. We've discussed Boyle's law already, and we've gotten the equation for Boyle's law. P1 V1 is equals to P2 V2, right? So for this particular class, we are going to be discussing how to apply the Boyle's law to calculate the volume of a trapped gas in a cylindrical tube by a column of mercury. That's okay. So this question, I had to discuss this topic because I've seen this question severally in JAM past question papers, most especially JAM and some other examinations, and then also in WAEC and NECO. And from my basic interactions, students always find it difficult to interpret and understand what happens when the tube is held vertical, horizontal, or it is held upside down. Okay, so that is what we're going to discuss in this particular topic. So I hope you have your writing materials ready. But before then, please, um, if you have not subscribed to this channel, please subscribe to this channel. This is Noble Mind Science Tutors Online, and we are here to bring physics direct to your very doorstep. Okay, so I remain on Tobo Michael, and I am anchoring this lecture. You can reach us via the WhatsApp number that is showing on your screen. Right. So without wasting much time, let's go straight to the discussion of today. Application of Boyle's laws to a trapped gas in a cylindrical tube by a column of mercury. Okay, so if you have gone through Boyle's law or some past questions, you would have seen this type of diagram. Is that okay? So this is um, this is the column of mercury, and then there's a gas here. So this is a uniform capillary tube. This is a uniform capillary tube. So this is the length of the mercury, and then this length of the gas also represent the volume of the gas that is trapped at this point. Now, when this tube is held vertical with the closed end at the bottom, okay, there is an equation for the pressure that is acting on there's an equation for the pressure of the gas. Okay, then when the tube is inverted, that is the closed end is at the top and the open end is at the bottom, there's also an equation for that. Then when the tube is held horizontal, there's an equation for that. So that is what we want to discuss in this particular class. Okay, so when a tube of uniform cross section closed at one end contains a fixed mass of gas or air, which is sealed by a column of mercury of length x centimeters, the pressure exerted on the gas will be, that's what we want to discuss. So when the tube is vertical with closed end at the bottom, the pressure of the gas will be equals to atmospheric pressure, right? That is the pressure on the gas will be equals to the pressure of the atmosphere plus the pressure exerted by this height of mercury. So when the tube is held vertical with the closed end at the bottom, the pressure on the gas is equals to atmospheric pressure plus the pressure exerted by the length of this mercury, and that is equals to atmospheric pressure plus x. This x represents the length of this mercury. So that gives you this particular equation. I want you to take note of this, right? Then when the tube is inverted, that is the closed end is at the top, while the open is at the bottom. The pressure on the gas will be equals to atmospheric pressure minus the pressure due to this length of mercury. So, and that gives you this equation. that gives you this equation. All right, so we have gotten two conditions now. Then the third one, the third condition is when the tube is held horizontal. So when the tube is held horizontal, the pressure on the gas is just equals to atmospheric pressure, and that is it. The pressure in the gas is just equals to the atmospheric pressure. So when the tube is held horizontal, the pressure is just due to the pressure of the atmosphere, and that is equals to P. I want you to take note of, I said it before, that the volume of the gas is equal to the length of the column of trapped gas. Okay, so that is what I've mentioned before. Alright, so these are the three conditions which can apply to this gas that is trapped by this length of mercury column. Okay, so if you want to now use this equation that we have gotten to solve some problems, how do you now apply them? That's the next thing that we want to discuss now. How do you apply this equation that we have gotten to solve problem using the Boyle's law? So that is our next discussion. Okay, so using the Boyle's law, we can use the Boyle's law to actually find the volume of the trapped gas, right, at different conditions. When the tube is held vertical, or when it is held upside down, that is inverted. So for in this particular case, when the tube is held vertical with the closed end at the bottom, we've said that the pressure will be equal to what? The atmospheric pressure plus the pressure due to the length of mercury here. That would be the pressure on the gas. So if you take Boyle's law says that P1 V1 is equal to P2 V2. This cannot be used to derive the relationship between this situation, the second situation that we discuss, and the third situation that we discuss. Okay, so as I've said before, we know that volume is equal to length times area. Okay, volume is length times area. So if we are going to now use this Boyle's law now to solve in the situation between A and B, this is how you go about it, right? So for A, the pressure of the gas, the pressure on this gas equals to atmospheric pressure plus the pressure due to atmospheric pressure P plus the pressure due to the length of the mercury, which is X. This is the pressure on the gas. So, and that will now be our P1. Then in this one, V1 is equals to this length of mercury, which is equals to Y1 times A. You can put the A there because the A definitely will also cancel out. We said that volume is equals to length times area. Okay, so now if this tube is now inverted, which is the situation of B, we have that in B, the P2 will be equals to what? To atmospheric pressure, which is P minus X. So this is our P2. Then V2 is equals to Y2 times A. So if we now apply Boyle's law, we have that P1 V1 equals to P2 V2. So this is where the application of Boyle's law now comes in. So we have said that P1 is equals to P plus X, and we have said that V1 is equals to Y1 times A. So this is now equals to P2, which is equals to P minus X, and V2 is equals to Y2 minus A. write it as A and B. So this A can cancel out, so that your equation now will now be P plus X times Y1 is equals to P minus X multiplied by Y2. Okay, so this is the equation. So in case you are given a situation like this, where the tube is held vertical with the closed end at the bottom, and then the tube is now inverted with the closed end at the top, this is the equation that applies. We have said that when the tube is inverted, the pressure on the gas equals to atmospheric pressure minus the pressure due to the length of mercury column. And when the tube is standing upright with the bottom, with the closed end at the bottom, it is the atmospheric pressure plus the length of mercury column. So that gives you P1, and then your V1 is the volume to the length of this gas. Then your P2 is P atmospheric pressure minus X, which is length of mercury, and your V2 is the volume of the gas at this. So with this now you can find the volume of the gas at any of the situations. That's okay. So this is the equation. This is how to apply gas Boyle's law to this situation. Now the other cases, when the tube is initially held vertical with the closed end at the bottom, and maybe the tube is now held horizontal. Okay, so which equation applies? That is the next situation that we're going to look at now. Okay, so this is the next situation. Just like as we did in the first case, in the first one that we just discussed, that first one we said that when the tube is held vertical and the closed end is at the bottom, the pressure on the gas, which is P1, is equals to P plus X. That was what we said before. So that one is clear to you. Then the volume, the V1 is equals to Y1 times A. Okay. Then in this situation now, we said that the pressure on this gas is only atmospheric pressure, which is just P. Then the volume of the gas, which is V2, is equals to okay, so V3 V3 is equals to Y3 times A. So applying the Boyle's law, P1 V1 equals to P2 V2, you will have that P1 is P plus X all multiplied by Y1 times A equals to P2, which is P, times Y3 times A. So as we said before, this A will cancel out. Okay, so that in this situation you have that P1 times Y1 is equals to times V1 is equals to P times Y3. Okay, so this is the equation that applies when you have these two situations. This is the equation that applies when the tube is held vertical with the closed end at the bottom, and when it is held horizontal. This is the equation. Don't forget that when it is held vertical with the closed end at the bottom, the pressure on the gas is atmospheric pressure plus the length of the mercury. When it is held horizontal, the pressure on the gas is just atmospheric pressure. I hope you can differentiate this. Please take note of that. Is that okay? Please take note of that. Okay, so the next situation I want to look at now is this. In this situation, the tube is inverted with the closed end at the top, and then it is held horizontal. So when the tube is inverted, we said that the pressure P1 will be equals to what? it will be atmospheric pressure minus the pressure due to the length of Mercury, and V1 is the same like what we said before. So in this case we are looking at it as P2. We said in the second condition. Okay, so we can have it like that, right? So we can have it like that, that V2 will give us Y2. Just following the numbering, it has not this one, the P2. Just take note that we are relating the pressure in the second condition to the pressure in the third condition or the third situation. That's why you are seeing P2 V2. Okay, so in this particular instance, this will be the P2 initial pressure, initial volume. Then when the tube is head horizontal, that's what we just discussed now. We said that pressure on the gas, which is P3, is equals to P, and the volume, which is Y3, is equals to V3, is equals to Y3. Okay, so here now we can use the Boyle's law. Say P2 V2 is equals to P3 V3. So when you substitute here, you are going to have P minus X as your P2 and Y2 times area as your V2. Then you have your P3 is P times your V3, which is Y3. Y3 times A. Okay, so this will cancel out, the A will cancel out normally as we discussed before, and then your equation will now be P minus X times Y2 equals to P Y3. Please take note of all these equations. I'm deriving all these equations because we'll use them to solve later on. I'm just taking my time to make sure that we get all these equations right, so that when we want to use them to solve, you will not have any problem. Is that okay? So all that I've written here is what I've already written down here. So I'm just trying to demonstrate how I got all these ones so that you will not be confused. Okay, so this is how you can apply the Boyle's law in these situations. Okay, so generally with all these conditions that we have discussed, you can actually have an equation that will connect all of them together. Remember that from the Boyle's law, we've gotten that P1 V1 is equal to P2 V2, and we said that P2 V2 is equal to P3 V3. So if you go back, you see that your P1 V1 is equal to P plus X, all bracket Y1, and your P2 V2 is P minus S, all bracket Y2, and then your P3 V3 is PY3. Is that okay? So this is the general equation for connecting all of them. So depending on the equation that you are giving, you can actually use any of these equations to solve and get your answers correctly. Okay, so I hope you understand, but for you to get a better understanding, you must solve a problem. That is what I believe. Everything I've said now, they look like grammar and confusion, but when you use them to solve a problem, you will get a better understanding. So let's go straight and solve some problems now. Let's go. Okay, so this is a question, and I represented the question already on this diagram. So let's just look at this question together and then see how we can solve it, right? So a thread of mercury of length 12 centimeters is used to trap some air in a capillary tube with uniform cross-sectional area and close at one end. Okay, so with the tube vertical and the closed end at the bottom, the length of the trap air is 25 centimeters. And that is what you have here. This is the condition A here. That's what is stated here. So this is, let me say A. This condition A. Now it said calculate the length of the air column when the tube is set horizontal. So find this length column, then vertical with the closed end at the top. That is when it is inverted. Take atmospheric pressure to be 76 centimeter of mercury. Okay, so if you look at this question, if you go back to what we just discussed, you find out that everything is just It's just for you to bring out the information there. But here I've already drawn the information here, so I think this makes it easy for you to understand, right? The length of the mercury column does not change, right? So what we are looking for now is the volume, the length of the air that is trapped when the tube is changing positions. Okay, so here in this situation we've told that P1 for this A, P1 is equals to what? Is atmospheric pressure plus pressure due to mercury column plus X. That is what we said from that equation. Okay, so that is P1. Then V1 is equals to what? The length of the air column, which is 25 centimeters. And this one is equals to atmospheric pressure, which is 76, plus what? The length of the mercury column is what? 12. So that gives you what? 80. That gives you 88 centimeters. That gives you 88 centimeters. Fine. Centimeters mercury. 88 centimeters mercury. Okay, so now this is your first situation. Then when the tube is now head horizontal, what will be your P2? When it is head horizontal, that is for condition B. This is condition A. Condition B. When it is head horizontal, P2 is equals to what? We said it's equals to atmospheric pressure, which is equals to atmospheric pressure is what? 76 centimeter mercury. It is given to us already in the question, that is this. Then your V2 is what you are doing, what is what you are looking for. Okay, so applying the Boyle's law now, you have that P1 V1 is equals to P2 V2. Okay, so your P1 is equals to 88 times your V1, which is 25, is equals to P2, which is 76, times your V2, which is what you are looking for. So make your V2 the subject of this formula. You will have V2 is equals to 88 times 25 all divided by 76. Right, so if you work this out, you can work this one out so that you have your answer. So if you work this out, you are going to have 28.95 centimeters as your V2 when the tube is head horizontal. You've had 28.95 centimeters when the tube is head horizontal. Is that okay? So that is for that. Now, when the tube is head vertical with the closed end at the top, that is condition at C. That is condition at C. So we already know our P1 V1 already. So what we are going to look for now is our P3 V3 in this particular instance. So your P3, when the tube is head vertical or inverted, we said that pressure is equals to atmospheric pressure minus pressure due to the length of mercury. So that would be 76 minus 12. So this will give us 76 minus 12 is equals to 64 centimeter of mercury. So this will be your P3. Then your V3 your V3 is equals to what you are looking for. That's what you don't know. Your V3 is what you don't know. So let me create some space here. So I hope you followed. So let me just create some space here so that we can just do some. Let me clean all this. Okay. All right. So I have. Okay. So just okay. So let me write this properly here so that it will be clear. Okay. So as I said, your P3 is equals to 76 minus 12, and that gives us 64 centimeters of mercury, and your V3 is what I said we are looking for. So P1V1, we already know that. So say P1V1 is equals to P3V3. So your V3 equals to P1V1 all over P3. So if you substitute this equation, you are going to have 88 times 25, which was to go before, so P1V1 all over your P3, which is 64. So if you work this out, you have that your volume in this system will be 34.38 centimeters. So you can see how we are been able to use this Boyle's law or apply this Boyle's law to solve problems on this gas that is trapped by a length of mercury. Is that okay? So this is how to actually apply it. I hope you followed this from, the space here was not too much, so I had to manage, but you follow from the beginning, you have everything clear. So that's okay. So this is how to actually apply this equation to solve problems that are related to this trapped gas on a mercury by a length of mercury. Okay. So let's see other areas where we can actually apply this Boyle's law to. Okay, so we can also apply this Boyle's law to a trapped or to an air bubble that is under a water body or that is under a lake. We can apply it to an air bubble that is under a lake. That's okay. So for an air bubble that is under a lake, this is assuming this is an air bubble A that is under a lake, that's at the bottom of the lake. The pressure that will be on this air bubble at this bottom of the lake is equal to the atmospheric pressure plus the pressure due to this height of water column. And from our study, it is discovered that what atmosphere of pressure support a height of 10 meters of water. So the pressure at this bottom on this air bubble is equals to 1 atmosphere of pressure, which is equals to 10 meters of water, plus the height, plus this height of water. That's okay. Then when this bubble rises to the surface, just before the surface, the pressure on the air bubble is equals to atmospheric pressure. And that is what we have in these equations that are here. Okay. So just before the surface, the pressure on the air bubble is equals to atmospheric pressure. Then at the bottom is equals to the atmospheric pressure 10 meters plus the height of the depth of the lake. Okay. So if you apply Boyle's law, you have that P1V1 is equal to P2V2. We have P1 is equals to this pressure, this atmospheric pressure plus the height, plus V1, which is given to you, is equals to the pressure at when the bubble is just close to the surface, and then V2. So with that, you can actually use to solve some problems on this particular situation or case. So we are going to solve a problem now on this particular um, situation so that we can understand it better, right? So let's look at this problem. So this question says that an air bubble of volume 6 centimeter cube rises from the bottom to the top of a swimming pool which is 50-meter deep. What will be the volume of the air bubble just below the pool surface if the atmospheric pressure is equivalent to 10 meters of water? Fine. So in this particular question, you are giving the air bubble, the volume of the air bubble V1 is given to you to be 6 centimeters cube, right? Then the depth of the lake, the depth or the height is equals to 15 meters. Then we have said that they've given us that 1 atmosphere of pressure will support 10 meters of water. 10 meters of water. That's H2. Put it that's H2 of water. And this is 10 meters of water. That is 10 meters of water, right? Then okay, so from this particular your P1, this is your V1, then your P1 at the bottom is equal to atmospheric pressure plus the height of the water, so which is equals to 10 plus 15, and that gives us 25 meters. Okay, then your just at the surface, the pressure is equal to atmospheric pressure, which is equal to 10 meters. Then the volume is what you don't know. That's what you are looking for. So from P1 V1 equals to P2 V2, you will substitute into this equation. You have that V2 P1 is equals to 25 times 6 is equals to P2, which is 10 times V2. So divide both sides by 10 to make V2 your subject of formula. You have V2 will be equals to 25 times 6 all over 10. Okay, so by the time you work this out with your calculators, you are going to have so when you do this calculation, you are going to have 15 centimeters cube as the volume of the air bubble just below the surface. Alright, so this is how to actually apply this Boyle's law to solve all these types of problems. So whatever problem you have, the most important thing is for you to know which of the equations to apply. Once you know the equations to apply, it becomes very easy for you. Alright, so that is it. So I hope this one is clear and understandable. You can check your textbook and solve more problems on this, right? So please, this is our test page. As I always said, please don't skip it. Try and go through these questions and solve them. An air column 10 centimeter in length is trapped into the seed end of a capillary tube by 15 centimeter column of mercury with the tube head vertically as shown below. On inverting the tube, the air column becomes 15 centimeter long. What is the atmospheric pressure during the experiment? So this one you are giving the the length of Mercury, and you're also given the length of the air column. But here, the atmospheric pressure is not given to you. So when the tube is held vertical, you should know what the atmospheric pressure is, which is P plus the length of Mercury column. Then when it is inverted, it will be P minus the length of Mercury column. Then you know your volume. Then P1 V1 is equal to P2 V2, and then your answer comes out readily with ease for you. I hope that's enough hint for you. These are jam questions. Then the second one is a uniform capillary tube closed at one end contained dry air trapped by a thread of mercury this long. When the tube was held horizontally, the length of the air column was this was 5.0 times 10⁻³ meter. When it was held vertically with the closed end downwards, the length was 4.5 times 10⁻². Determine the value of the atmospheric pressure. Okay, so this one is almost like this. If you can solve this number one, you should be able to solve this. Then this is just how to do with that type of one we solve now on the leak. Okay guys, so I hope this is relatively simple for you. Please go through this video. You can go back again, go through this video so that you get a real understanding of this topic. Then solve more problems too, right? Solve more problems. Okay, so this is where we're stopping our class for now. Before I go, please subscribe to our channel, give us a like, give us a thumbs up, give us a comment, so that we'll know that you are enjoying what we are doing. We really need feedback, because it is your feedback that will actually spur us to continue in this journey of preparing this lecture material. It is not really easy, putting everything together and all that. So we actually need your encouragement. So the only way you can encourage us is for you to give us a like, give us a thumbs up, invite your friends to come and enjoy this too, and let them subscribe to this channel. You can reach us through the WhatsApp number that's showing on your screen, and then this is Nobleman Science Tutors Online. Thank you so much for viewing. Thank you for your time. We hope that you are studying your books, and then prepare well. That's okay. There is no hard and fast rules. As you read and you prepare, solve problems, you get acquainted, you get used to most of the rudiments in physics, right? So thank you so much for your time. We'll see you in our next class. Thanks.